These are the notes for section 8.2, inverse relations and functions. Now the reason we're studying inverses right now is because in math, inverses are used to help define other functions. For example, when you were in first grade or perhaps kindergarten, your teacher may have used the fact that substitution is the inverse of addition to help you learn subtraction after you already learned addition. It gave you a way to connect it to something you already know. In a little while, we are going to use inverses to define what a logarithm is. So we need to study what inverses are and how to find them in this section. So we'll start by the word inverse. You find the inverse when you switch the domain and range of a relation. And I do mean literally switch it. You pick up the x and the y and you switch places with them. So the second part of the definition, if you're given a relation in the ordered pair A and B, then the inverse is actually you pick up the A's and B's and switch places, and then the B is first and then the A. So we'll look at an example of that in just a moment. Another part of what I call the reading lesson, right here when we write a letter, for example, r to the -1, this is not a negative exponent. It just means the inverse of r, in the same way that it meant inverse back when we were studying matrices. So that's just a point of clarification. So first quick example here. If Q is defined to be these three ordered pairs, find the inverse of Q. And so you literally do just switch around the x and the y. So 1, 2 is the first ordered pair in the inverse, and then 4, 1, and then 2, 6. All right, simple enough. Now let's ask ourselves a question or two. Is Q itself, is Q a function? So if we remind ourselves, each x can only have one y. We look here, 2 input, 1 output. 1 input 4 is the output, and then 2 input 6 output. So does each x have only one y? No, we have a problem here. The 2 mapping to the 1 and the 2 mapping to the 6, this would not pass the vertical line test. So is Q a function? We'd have to say no. How about its inverse? Is Q inverse a function? Well, just checking, 1 maps to 2, 4 to 1, and 2 to 6. So this is fine. Is Q inverse a function? Yes. So sometimes they'll both be functions, and sometimes just one will be, or perhaps neither one. And we do have a special term for those where both the function and its inverse, I should say both the relation and its inverse, are both functions. And that is the definition to a one-to-one function. Any function whose inverse is also a function. And if you're looking at the graphs of these, the graph of a one-to-one function would pass both a vertical line test and a horizontal line test. And by doing that, by drawing those lines, you're really testing the function by the vertical line, and you're testing the inverse by the horizontal line. And I think that'll become more apparent when we look at the graphs of these in your exercises. So now the steps here. When we're given an equation and we need to find the inverse of it, please write these down in your notes. Step 1, write the equation in y equals form. This would especially be true if it was written in function notation form and they had f of x equals the equation. So you remove the function notation and put it in the y equals form. Then you actually literally pick up the x and y, switch their locations, and put them back down again. So you truly are switching the domain and the range. And then you solve the new equation for y. So now let's do a couple examples where we have to find the inverse. So since this is written in function notation, let's rewrite it as y equals 2x plus 4. Now we're going to pick up the x, pick up the y, and switch them. So we'll write this x equals 2y plus 4. And now just do your solving techniques. Continue up here. We'll subtract a 4 from both sides. And then we'll divide both sides by 2. Well, divide everything by 2. So then I'll get x over 2 minus 2 equals y. And that is the inverse of the original function. So now let's do one that may be a little bit more challenging. Again, take out the function notation and put in the y equals x to the third minus 2. Once again, pick up the x and y, change their locations, and set them back down again. So I get x equals y to the third minus 2. Add a 2 to both sides. Continue up here. X plus 2 equals y to the third. And then solving for y, we would take the cube root of both sides. Now on a cube root, there isn't a plus minus, but you'll see in your exercises when you're finding the inverse of an x squared, which the graph is a parabola, and if you just take the positive square root of both sides, then when you graph your inverse function, you'll only have half of a parabola. So you actually have to, remember the plus minus sign, and if you want to see the graph of it on your calcs, you have to enter the positive square root on one of your y equals, and then go down a line, and then graph the negative square root, and it will graph the parabola in both pieces, so you'll see the whole thing. Now this is where the section we did yesterday, or earlier, 8.1, is combined with section 8.2. You will be asked to determine if two equations are inverses of each other. So to do that, you put one equation, the first, into the second, and we'll call this fog, and see if the answer simplifies down to x. And then you put the second one into the first one, we can call that goff, and see if that answer is also x. So in other words, if both fog and goff, if they both simplify down to the letter x, then we can definitely say yes, the two equations are functions. So let's try one of those. So if I were to take this first one and put it in to the second one, I would get negative 2x plus 4. And then doing distribution here, I would get negative 4x minus 8. This definitely did not reduce down. This answer is not x. So I can say for certain that no, these two equations are not inverses of each other. All right, let's try this example. Remember, we have to do both fog and goff and get an x as a simplified answer both ways. So let's take this second, 3x plus 6, and let's put it into that first equation. So I have 1/3 times 3x plus 6, and then minus 2. So let's simplify this. Using distribution, 1/3 times 3 is 1, so I have x. 1/3 times 6 is 2, positive 2, and then I'm subtracting the negative 2, and that does simplify just down to x. So that's putting the first and the second. Let's go the other way, and let's put the second one, or the first one into the second, I guess, if I said that right. So I have 3 times 1/3 x minus 2, and then I'm adding a 6 to that. So again, let's do distribution and simplify. I have x minus 6 plus 6, which once again simplifies to x. Since Fogg and Goff both ways simplified to x, we can say that yes, these two are inverses of each other. All right, the last part of 8.2. As you're doing the exercises, I would like you to consider the question, how are the graphs of a function and the graph of its inverse related to each other? You know, is one flipped over? If so, what is it flipped over? Are they mirror images? Are they backwards? Are they upside down? So keep that in mind when you're doing your exercises and be prepared to answer this question. And if you can't figure it out, please bring it up and ask in class. Thanks.